Lee, the SmartZoom 5 is one of your pieces of equipment I'm not familiar with, so what applications does this piece of equipment lend itself to firstly?
We use it in quite a wide range of industries, to be honest. Everything from aerospace, we've got obviously a circuit board for the electronics, do a lot within automotive and quite an awful lot in medical too. Everything from inspecting a part to doing some sort of basic measurements, 3D measurements. It allows then the user or somebody who's inspecting the components to get a really good understanding of what's actually happening on the surface of that sample.
I mean, to me, I'm looking at this and I can't figure out how it measures a 3D component, because it looks to me like it's taking a plan view perspective of the components. How does this work?
Yeah, well, in a sense, that's kind of what it's doing. It's taking a plan view, but it's actually making a lot of plan views. So the way it works is it will actually use something from a depth of field point of view. So we'll take an image from the very, very bottom of the sample. We'll use Z-stack using the motor in the actual microscope itself. And then we will build up a number of images in the best point of focus. And that then allows us to get a nice fully focused image. From that image, we've then got all that data that we can actually then create a nice 3D model of that sample as well.
I mean that's fascinating. You're taking effectively like photos and creating a 3D image from a plan view. Now, how accurate is this?
Okay, so we work on obviously optics and obviously on reflection and any other sort of defects that might be on the actual sample. So what we try to understand is the actual repeatability of the motor that's driving that Z-stack. So within the actual Z-stack itself, we have an accuracy of around about 1 micron in the Z.
That should suffice most components.
Yeah, it should do. Yeah, obviously, if it's a sub-micron measurement, then we have a product for that and a different solution for that too.
Lee, thank you.
Thank you. Cheers.